Good morning, all of you. I'm Shravan Kumar from Delsoft Technologies, New Delhi, and I'm going to give you a presentation on this software called Target 3001. That is a CAD CAE software for integrated PCB design and simulation. So this is a complete PCB designing tool for doing any kind of PCB design or circuit simulation of electronic circuit and electrical circuit. So it comes in different languages. Now, it is an integrated PCB design and simulation software, and it has various features like schematic for doing the entries for designing any circuit. You can drag and drop simply the components and into the environment and create your own circuit. Then there is a AD analog digital mixed mode simulation for doing any simulation for transient analysis, AC analysis, DC analysis, and there are probes available to analyze the voltage and current at particular point. Then there is a counter outer router. Outer router are of three types: counter, hybrid, and external outer router electrized there. So there are three types of auto router given for auto routing the signals. Then auto placer is there for auto placing the component into the PCB to give the component at a optimized space. And PCB layout 3D view is there. Then EMC analysis check for doing the electromagnetic analysis, and you can create the front panel layout of any circuit, and it also give you the manufacturing data for production process in all industry standards. So it will provide you the Gerber data, Gerber layout for doing the process of that PCB into your labs, or you can create your own PCB by creating the CNC file formats uh, as per industry standards. Okay. Now, why should you use it? So it is very easy to use software, and it comes in the Windows 7, 8, XP. You can install it, and it has a GUI interface, and its working is divided into four parts: schematic, simulation, layout, and 3D view of the same circuit. Okay, then you can toggle between the schematic and layout in separate windows or into the combined windows. And there are various features like you can renumbering the pins, you can swap the gates of the schematics layout, and it has a very high accuracy. And there is a component server of 36,000 plus component. Online access is there, and there is an upgrade of the component also. You can update the components library and the software through online portal. Okay, and the components can be edited also in schematic or layout. 50 steps of undo and redo is available. Then it has an external interface with the different softwares like Eagle or CAD, pads, different software it has available with the. Then there is a Electra auto router given for auto routing the large signals, and two inbuilt auto router is there, hybrid and counter, and you can create the netlist of the any circuit. Then you can create the BOMs. Now it has a component management system, CMS is there, and it has the components provided through different distributors, and their data sheets are available. So there are multiple components of different manufacturer and different specifications. Okay, and their free updates is available if you purchase the software. The free update for 1 year is available for the current version that you have purchased. Mm. Then it has the interface with all the popular softwares: Protel, Eagle, Orchid. Now comes the schematic design. So what we do in schematic, we create a electrical logic sketch. Like sketching, we just put uh, different components from the library and drag it drop into the environment. And then there is a wire given, electrical wire. We can create circuits. We can create the circuits through those wires and join them, and we can provide the inputs by double clicking on the nodes and provide the input as a parameter. After the schematic design, so it has the same information. I just skip it. After the schematic, we go to the simulation part. In simulation, what we do, we just go to the simulation assistant and provide the simulation parameter like timing, time step, maximum step to analyze our circuit. And it has various type of analysis like transient analysis, AC analysis, DC analysis. Then PW editor graphical interface is there. Model browser is available with the different manufacturers. Then the simulation is based on SPICE 3F5 and PSPICE compatible. And mixed mode simulation is there, analog plus digital. Okay, and the simulation has a graph calculator in which you can calculate some of the values like RMS value, log value, dB value, different values of the different signals. Okay, so this is the features of the simulation. Easy model import export is there. Model browser is available. Sub circuit generator is there. You can create your own components there. Then PWL editor, pulse width editor. Now after the simulation, when you create the PCB, the auto placer automatically works. So what it does, it will place your components to the optimized space in the PCB. Okay, so you have the option, you can place the component inside the PCB or outside the PCB. You have the option for placing the SMDs on top, on bottom. Okay, and you can choose the order of placing the by component name, random or fat first, small first. You can choose those options. When you start the auto placer, it will place the component in the optimized space in the PCB. Now auto router. So after placing the components in the optimized space in the PCB, we have to go for auto routing. So uh, auto route the signals into the optimized space so that short circuiting doesn't occur there. So there are three types of auto router: counter auto router, hybrid, and electra auto router. So we can choose between these two, counter and hybrid. And electra is an external auto router that is available with the software, and we can choose for a larger circuit. And in auto routing, you can choose various parameters like drill hole diameter, track width, track spacing. You can choose the algorithm like disentangling and optimization of the circuit, and route layers, copper top or copper bottom. These are the options available in the auto routing. Now, after creating the layout, you can choose for 3D view. In 3D view, you can see the actual view of the circuit. After making any circuit, you can see the actual view. And there are also options available like PCB, signal, layers, and package. So you can choose one by one the package, signals, layers, or PCB to see the one by one view. So in the larger circuit, you can see your components by clicking and unclicking them. And then EMC analysis check is there, electromagnetic analysis, and that has also various parameters like radiation coupling, galvanic coupling, track length, inductive coupling, coupling factors. Okay, so you can choose for EMC analysis check. Also, after the layout, you can create the front panel layout. Okay, so there is also a tab given there for creating front panel layout. You don't have to hassle anymore. You can create easily the front panel layout. Now, some benefits of Target 3000 that actually it has the component server, so you can easily download your components and the updates of the software that is online, and user-friendly license there. No hassle for dongle licensing or network licensing. No activation codes, no hardware protected keys. All online updates are there. Okay, so I'll just show you on the software how we can create any circuit. Okay, so this is the environment of the software. Okay. Here first we have to go for the import component. Okay, so this component browser has the various components available here. Here you can see the components are given by name, like connector, socket, converters, crystal, diodes. So whatever component you click, you will have the component related to those name, like bridge rectifier, diac, IR diode, LEDs. Okay, different diodes are available. So when you click on any of the component, you can see the three view of these components. One is schematic view, one is package view, and one is 3D view. Okay. Schematic view, package view, and 3D view. And these are the parameters given, like manufacturer, package type, power diode, and its values and description of the nodes, and data sheets is available, and you can buy the component also. The shops is available. Okay, so you can choose this component from here, an import component. When you click on import component, the component would attach with your cursor, and you can place it into the environment. Okay, and you can rotate it in by right clicking on it. You can place multiple components at a time. Okay, okay. So this is for importing the component. Also, you can write the name of the component, like you need a register. You can search by name. Okay, by name you can search, and components are available according to DIN package and IEEE package. You can choose between these two. When you import component, it will come here. So we just make one short circuit to give you the overview of the working of the software. So just place one register here, and there are some other component libraries given here according to their package type, like the power source is there, ground, connectors, resistor, inductor, diodes. So you can just drag and drop and click into the environment. So we just place one sine wave here. Okay. Place one diode. Now we'll take a 2-pin connector here. As you know, power source is external in any circuit, so we just take one 2-pin connector so that our circuit would be complete in the PCB. So now we just connect the circuit through this place wire. It is very easy to connect. We just have to connect this cross wire from one to one by the endpoints. Okay. So we just put one ground here. Okay. So the circuit is complete now. Now we have to change the parameters. Okay. You have to double click on any component and give the parameters. Like I gave 12 volt, and for resistor I will give 300 ohm, and this diode I'll select the default values. Here you can change the rename the signal's name also. Like if you click on this signal, you can choose the name. Like this is the input, so I'll give the in, and this is output, so I'll give the out. So it helps in the bigger circuit that your output and input would be identified, as there are many components available, so the signal wires would be many more. Okay, so now as I've told you that this working of the software divided into 4 parts. Like one is schematic. So we have done the schematic entry and set the parameters. Now we go to the simulation. Okay, for simulation there is a tab, start the simulation assistant. Okay, here you can change the parameters. For the simulation parameters, simulation end timing, at what time your simulation will run, the begin save at time, step at t is equal to d0, and maximum step. Okay, so these parameters you can change. So our result will vary according to this simulation timing and our component parameters. Okay, so we just start this simulation, and this is your virtual oscilloscope. Here you're seeing that there is a overlapping of these signals. So there is a graph calculator given. You can analyze the signal one by one from here. You can choose show none. First you click on V in and then V out, or you can choose the V out as individual. You can see that half wave activation is there. Okay, this is a current. So you can analyze signal one by one, or you can compare those two signals, or you can see the combined view of any signal. So this is the result. Now there is an editor of these graphs. So in editor there are various values available, like derivative, integral, minimum, maximum, DC, RMS. Various values are available. These values can be calculated through this graph. Like I've choose RMS value of any signal. Let's say V in signal. So if I click on equals, it will give you the value of 8.4847, and if I click on OK, it will give you the graph of that RMS value. So this purple line will show you the RMS value of this graph. Okay. So likewise, you can calculate different values from here. Apart from the transient analysis, you can choose the various analysis like AC analysis, DC analysis. You can choose the probes also. For probes, you have to choose for select particular voltages and current. So if you want to get values, voltage or current values at any particular instant of time, so you have to add those values like voltage against ground, or you want voltage against voltage, or current, or digital values. So if you click on voltage against ground, one probe is attached with your cursor, and if you click on any signal, it will give you signal V in added, so that it will give you the values for V in only. And if you click on V out, it will give you the V out value. So these two signals has been added. So if you click on OK, start simulation, it will give you those two values only, V in and V out. So these were probes for having the voltage and current value at particular instant of time. Okay, you can change the color of these signals also. Pen type, you can define pen width, you can define. Okay, so this is a simulation part. After the simulation, we can go for PCB designing. We can go for PCB designing. For PCB designing, there is a simple go to PCB view tab. If you click on this, first you will get the window for size of the PCB. So you can change the width and height from here, or you can directly click the complete PCB outline. So if you click on this complete PCB outline, you will first get auto placer. As I told you in the presentation, you will get auto placer first before creating any layout. So you can choose between inside the PCB or outside. You just choose inside the PCB, place SMDs on top, then start. So here we can see our components are placed at optimized space. Here you can simply drag this PCB size and change the size of the PCB, okay, as per your requirement. This one. Now as auto placer has worked now, so we just choose for auto routing. So these green signals you are seeing, that you have to optimize so that they did not occur any short circuit. So we just choose in action auto router. So as I told you, there are three types of auto router given. You can choose between these two, hybrid or counter. I choose hybrid. Here also you can see there are various parameters to change, like you can choose the order of the routing, like route thick signal first, route short signal first, and route only module. You can choose all module. Then signal tracks you can change, minimum track width, minimum track spacing. Then vias, drill hole diameter you can choose for minimum, thickness of the annual copper ring. Okay, then you can change the algorithm, like route memory structure first, escape vias, then disentangling, then the optimization. You can choose for higher optimization when there is a larger circuit, then connection involved in rule violation. Then when you operate it, already existing router signal can be routed again. then use of wires. So these are various algorithm you can choose. Then route layers are there. You can choose between copper top, copper bottom. So these are various parameters you can choose in routing. So we just when you start it, now these signals are routed now. If you click on view, 3D view, you can see the 3D view of the circuit. Okay, here you can see your circuit will look like this when you create it in real. So it will give you a virtual view. Okay, so here some features there like PCB layers, signals, package given. Okay, when you click on package, you can choose one by one package from here. Like if you click on D1, you can see your diodes is there, J1, your socket is there, R1, your register is there. So you can identify your components among these. Okay, so now to create this PCB, we we have to give this get this track layout, this one. So it has the feature of track layout also. So now schematic simulation and layout part is completed. 3D we have seen. Now we'll go to the manufacturing part, how you can manufacture this PCB. Okay, so in this layout section, when you go in file and input output formats, then production and engraving insulation channels. Okay, so this is the isolation milling wizard. Here you can see production type, double sided, single sided, copper top or copper bottom you can choose. You can choose any one of. Then there are various parameters. Now this output format, that is very important. So as we are seeing it, just for checking we are seeing that Gerber layout, so we'll create on X Gerber for checking. Otherwise if you want to create your PCB through these machines, like the software supports different machine format like HPGL, ISL, Proma, CNC, Charlie Robot, Colin Bus, LPKF. These are the various CNC machine formats that it supports. So when you create the file format on any of the machine, it will give you the drilling milling data, and you can send this data to these machine companies, and they'll give you the drilling hole of the PCB. So we just want to check this Gerber file. So we'll create on output format X Gerber for checking. Okay. And there are various parameter available here also. Fiducial drill, you can change the drill parameters. Copper top, various parameters given for copper top. In PCB outline you can change. Then your output, that GR file extension will create. So you can choose the path of the file. So that is GR extension. Okay, now you can start. Now we will select one blank page and open our GR file here. Okay, in input output format, file transfer documentation, read Xcarbon and Excel files. So if you click on this, you'll have the option of read file. You click on this. This one. This is your GR file, new.gr. When you open it, it will give you this track layout. So this is a final layout that comes for any circuit. So the track layout can be printed on the glass sheet. then further process can be done through this track layout. So this is a complete flow of the circuit, right from the schematic, simulation, layout, 3D view, and this track layout. Okay, so this is for analog circuit. Now I'll show you one of the digital circuit and how we can analyze in digital circuit. Just see this simple gate is available. It's 4011. So for analyzing in a digital circuit, there is a stimulator available that creates the binary input for any circuit. So if you click on stim, double click, simulation values, edit, and stimulus editor. So it will give you the input. Like you can put the input through this text. Like for 0 it is 1, for 1 it is 0, for 2 is 1. These are the time instants given here. Like if you can see 1011 for 0 to 3. So if you click on OK, you can see from 0 to 1 the input is 1. Then from 1 to 2 input is 0. Then 2 to 3 input is 1. And 3 to 4 input is 1. And further out also there is a 1. So this is the input given here. You can save it. Same in the other one. This is the input for other. Okay. And this is a reference signal. It is available in the reference signal, and you can this for output and this for input. So this is a difference between the analog signal and digital signal. That you have to create the input through this stimulators and get the output through this reference symbol output. And this is 4011 IC. So as you can see, there are other parts of the IC available here. So when you import any IC, the first there 3 pins would be imported, and other part would be available in the import rest of component. So if you click on import rest of components, the other part like other pins will be imported here, and its power input is there. This for power 147 pins. So you have to import it for other work like power symbols, but you have to use this 3 pin only for input and output. Okay, so if you click on simulation, the input is available in the analog and digital both part. So you can see the digital output here and analog output here. Okay, so here we have choose the output as the probes. So there is only one output given. So D out, and this is V signal. Okay, so this is the output. And there are various demo projects available. These are various demo projects that are available along with the software. You can create the PCB. See the 3D view. These are already made projects given along with the software. Okay. This is one oscillator circuit. You can choose the simulation. The output given. So likewise, you can create any circuit from here and see the output. So my presentation is over now. If you have any query, you can ask me.
Hello.
Yes.
When we'll do this EMC analysis, I mean at which part of this process we'll do that?
Okay. 1 second. I'll show you. This is the EMC check. These are the various parameters you can calculate the electromagnetic field,
Okay.
radiation coupling, galvanic coupling.
Okay.
So various will come out.
So it has to be done for layout, right?
Yeah, for layout.
For layout.
Yes.
Okay, thank you. Very good.
Okay.
And one more thing, how this software is different from the other existing one, means OrCAD, PCAD, and
Sir, there are
means any
various,
extra features.
yeah, various softwares are available, but they are available in different packages and different modules. So it has integrated all these things into one, that is schematic, simulation, layout. Because some of the software are available with this simulation only, and some of the package available for the layout only. And if they are
Oh,
giving the simulation and layout both, you have to integrate third-party softwares. So it has integrated all the modules into one. So complete right from the schematic to the manufacturing process also. So that is manufacturing data is not available with some of the softwares. So that is why it is different.
okay, okay.
Yes, sir.
Okay, okay, thank you.
Okay. Any other queries?
Nothing from my end.
Okay.
Thank you.
Hello. Do you
Yeah,
have
tell
any?
me.
Yeah. Do you have any query? All of you.
Uh, okay. Okay.
Your mics are now unmuted for query session. If you have any query, you can ask. Or if do not have audio facility, you can write your questions in the text box. Hello, yeah, Chandrika ma'am. Hello. There is nothing much difference, ma'am. There are two auto routers available there only. They are according to the difficulty of your circuit. So that is why Electra auto router is also there for doing the larger circuit. And counter is counter or hybrid. You can choose between these two. Both are same. I can show you according to the both of this auto routing. This is also almost same. Special vias are given for extra. Yeah. Hello? Okay. Any other queries? Yes, ma'am.
ಏನು ಬರುತ್ತೆ ಅಂತ ಕೇಳಿದ್ರು ಆ್ಯಂಡ್ ಈಕ್ವೇಷನ್ ಒಂದು ಅದನ್ನು ಮೈನಸ್ ಕೆ ಸಾರಿ ಪ್ಲಸ್ ಕೆ ಇಂಟು ವಿ ಐ ಅದು ವಿ ಹೀಗೆ ಬರುತ್ತೆ ಹೀಗೆ ಗೇನ್ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್.
Hello, ma'am. Do you have any query?
ವಿ ಏನು ವಿ ನಾಟ್ ಮೈನಸ್ ಕೆ ವಿ ಇಂಟು ವಿ. ನನಗೆ ಈಗ ಒಂದು ಈಕ್ವೇಷನ್ ಇದೆ ಕೆ ಎ ವಿ ಎ ಮೈನಸ್ ಕೆ ವಿ ವಿ. ಆಗ ಏನು ಮಾಡ್ತೀವಿ ಹಾಗೆ ನನಗೆ ಇನ್ನೊಂದು ಎರಡು ಪ್ಲಸ್ ಅನೇ ರೀತಿ ಮಾಡಿದ್ರೆ ಅದು ಹೇಗೆ ಒಂದು ಸಾಲ್ವ್ ಮಾಡೋದು ಒಂದು ಸಣ್ಣ ಒಂದು ಪ್ರಾಬ್ಲಮ್. ವಿ ನಾಟ್ ಇಕ್ವಲ್ ಟು 3va ಮೈನಸ್ 4vd ಪ್ಲಸ್ 2ab.
Hello.
ನಾನೇನು ಅನ್ಕೊಂಡೆ ಅಂದ್ರೆ ಐ ವಿಲ್ ಡೂ ದಿಸ್ ಮತ್ತೆ ಒಂದು ಪ್ರಾಬ್ಲಮ್ ಉಂಟಿಲ್ಲಿ ಆಲ್ರೆಡಿ ನೆಕ್ಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ಬಟ್ ಅಲ್ಲಿ ಅಷ್ಟೇ ಅಂದ್ರೆ ಇದೆಲ್ಲ ಪಾಸಿಟಿವ್ ಇರೋದು ನಿಮಗೆ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಇನ್ವರ್ಟಿಂಗ್ ಟರ್ಮಿನಲ್ ಮಾಡ್ಬೋದು. ಆದ್ಮೇಲೆ ಡಿಫರೆನ್ಸ್ ನೆಕ್ಸ್ಟ್ ಡಿಫರೆನ್ಶಿಯೇಟರ್ ಇಂಟಿಗ್ರೇಟರ್ ಮಾಡೋದಾ ಅಥವಾ ಇನ್ಸ್ಟ್ರುಮೆಂಟೇಷನ್
ಇನ್ಸ್ಟ್ರುಮೆಂಟೇಷನ್ ಮಾಡಿದ ಲ್ಯಾಬಿಗೆ ಟೈಮಿಂಗ್ ಮುಂದೆ ಹೇಳಿದ್ರೆ
ಯಾಕಂದ್ರೆ ನಮ್ಗೆ ಇನ್ನೊಂದು 1 ವೀಕ್ ಸಿಗ್ತಲ್ಲ ಈಗ ನೆಕ್ಸ್ಟ್ ವೀಕ್
ನಾನು ನನಗೆ ಶಿಫ್ಟ್ ಮಾಡಬೇಕು ಅನ್ಕೊಂಡಿದ್ದೆ. ಅವ್ರು ಬರುವಾಗ ಇನ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡುವಾಗ ಅಲ್ಲಿ ಎಲ್ಲ ಕೆಲಸ ಆಗ್ತಾ ಇತ್ತು, ಹಾಗಾಗಿ ನಮಗೆ ಅಲ್ಲಿಗೆ ಹೋಗ್ಲಿಕ್ಕೆ ಆಗಲಿಲ್ಲ. ಇಲ್ಲಾಂದ್ರೆ ಎ ಸಿ ರೂಮಿಗೆ ಶಿಫ್ಟ್ ಮಾಡಬೇಕು ಅದು ಈಗ ನಾನು ಅನ್ಕೊಂಡೆ ವರಿ ಮಾಡ್ಲಿಕ್ಕಿಲ್ಲ ಹೇಳುದು ನೆಕ್ಸ್ಟ್ ವೀಕ್ ಮಂಡೇ ಅವರಿಗೆ ಹೇಳು ಸೋಮವಾರದ್ದೇ ಮಂಗಳವಾರ ಇಲ್ಲ ರಜೆ, ಬುಧವಾರ ಗುರುವಾರ ಶುಕ್ರವಾರ ಶನಿವಾರ ಬುಧವಾರ. ಹಾಗಾಗಿ ಅವರಿಗೆ ಸರಿ ಆಗದಿದ್ರೆ ಹಿಂಗೆ ನೆಕ್ಸ್ಟ್